Eric Walker.
Testing, testing. All right. Thank you for inviting me. I see a few familiar faces. I've been teaching here in Baton Rouge for 15 years, so I've had quite a few of you come through our classes. Today we're going to talk a little bit about cloud computing, which I'm assuming a few of you have actually started playing with already. So we'll kind of cover some of the basics and kind of get you thinking about moving in that direction if you haven't already started. So the first thing here, basic characteristics of cloud computing. Why do I want to go there? What are the benefits? Why do I need to do this? The first thing I have listed here, on-demand service. If you think about the effort you need right now to spin up a new development system. All right, I got a new project we're working on. We want to roll this out in 6 months. So how do we do that? Well, we have to get hardware purchased. We have to get hardware delivered. We have to get it set up and configured. We need a platform to be put in place. And then my development team can actually start writing code, right? I don't want to wait 6 months to even get to that point. I'd rather have maybe somewhere in the next 20 minutes have that system spun up, ready to go, and start writing code. Right? So the time it takes to bring things online can be dramatically lessened with cloud systems. Network access. Access resources of the network or through standard client machines. I don't want to change any of that. I want still the application to be available, whether it's internal users in my corporate infrastructure, whether it's external users on the internet, vice versa, both ways. I still want that accessibility. Cloud computing allows that. Pooled resources. That's where you start getting into cost savings, right? So for me to go purchase the hardware to spin up this application, I'm going to dedicate a server or maybe a virtual machine for that. Whereas in a cloud environment, I spread that cost with other customers of that cloud service provider. All right, so the cloud provider buys the hardware, and then on top of that hardware, they sell me access to processing, computing power, along with 10,000s of other people. So pooled resources, elasticity is a huge thing. The ability to change dynamically the load that I put on that system. So I spun it up, I created this environment for an application based on a particular amount of workload, but then as things change, 6 months later this project has taken off, the amount of users we have using it has quadrupled. How do I change that? How do I modify that? Well, the elasticity of cloud systems allows me to expand that system fairly quickly. And many of the cloud providers provide an interface for it to do it for you. All right? So as certain performance goals are hit, it automatically increases the workload available for that product. And then it functions as a measured service. Pay only the used resources by providing metered billing. So instead of buying a whole bunch of equipment, which is an instant hit to the bank, I can spin up these systems as needed, spin them down when I don't. Once the project's over, I turn off that environment, and the building stops. As the project takes off, I spin up more systems, and that's a control process. So quite a few realistic characteristics of cloud computing, and those are benefits. So the primary benefits here, economic, pay-as-you-go principle versus capital expenditure. If I have to buy a whole new IT infrastructure, all of our systems are 3 to 5 years old, coming up for renewals, that's a big chunk of money. My accounting department's not happy about that. And the budget may not be there this year. Whereas with cloud computing, I spin up things as I need them. Agility allows me to be very quick and handy. As I said, a 6-month takeoff to get a project started versus a 2-day takeoff. All right, I can give my developers access to the cloud application and say, go, start it. Here's your parameters, here's your requirements. Start working on this today. You don't have to wait for the IT guys to go buy a bunch of new systems and get those plugged in and ready to go. So agility and then efficiency. Scalability makes IT management simpler. As I put these things in place, we become more efficient IT infrastructure. We save a lot of time doing our standard day-to-day stuff. The mistake is I can then shrink my IT staff. What you really want to do is now that your IT staff is more efficient, you want to leverage them and solve more problems. You want your IT staff Now we got a handle on our current systems. I want them going to each department and saying, what are your problems today, and how can we fix them for you? And add more features, add more systems, add more applications. All right. So it's very critical not to assume you're going to just start cutting heads because we went to cloud services. Now, the next thing I'm going to do is kind of break it down into different types of cloud systems. First one here is called infrastructure as a service. This is a cloud provider, or you may be doing this privately. We'll talk about public versus private here in a minute. This is a cloud scenario where I need a virtualization platform. All right, I need the ability to bring up virtual machines running a particular operating system, or maybe a whole array of different operating systems. And then on top of that, I'm going to add all the other features and platforms and systems and applications that I want to control it all. All right, so infrastructure as a service cloud is the virtualization layer and everything above. Now, many of the companies that offer these also have obviously lots of extra add-ons and features, but that's your primary thing is infrastructure as a service. So the driving force here, cost of ownership, save time, effort, cost involved in procuring and managing required infrastructure. Now, if you've already recently bought a lot of equipment, all right, you've recently redone your data centers, acquired a whole bunch of new hardware and so forth, doesn't mean you still can't go to the cloud. You would be doing infrastructure as a service, but you'd be doing it potentially privately, all right? So cost of ownership, speed of deployment, deployment resources substantially shorter than traditional computing system. If I go to Microsoft Azure right now or Amazon Web Services, I can have a virtual machine up and running in 10 minutes or less. And then it's ready for me to start doing something with it. I can install this on it, I can add this to it, I can attach it to my corporate infrastructure and have it start servicing my local internal users. The next option, platform as a service. I don't really want to handle all that virtualization stuff. I don't want to have to patch a server. I don't want to have to manage services and event logs. I would just want a place that I can do my development. I want to develop in Python. I want to develop in Visual Studio. I want somebody else to provide all of that stuff for me. Well, I need a platform as a service provider, whether it's public or private, but that's the idea. I need to develop in a particular style. I need to find a cloud provider that gives me that type of environment to work in. So driving force there, again, cost efficiency, save the cost of acquiring and maintaining that platform, and then the speed at which you can develop and test all at the same time. So as soon as I get my application fairly quickly up to a certain working level, I can start having access for my clients. And as we're going along, we're testing new features and opening those things up fairly quickly, but we're in production, so to speak, right? So the speed at which I can deliver applications is critical. The third one I have listed here, kind of what's considered the low-hanging fruit of cloud services. Software as a service. An example of this would be applications, all right? For years I've been rolling out Office applications along with my desktops. I've been licensing that, I've been patching that. A new version comes out, we evaluate it, we replace that, we license that, we patch that, repeat. I'm tired of that. Spend a lot of time, we've got help desk, I've got IT support that spends quite a bit of time just managing word processing and spreadsheet programs and email applications. I want to move that to the cloud. All right? That's the software as a service. So I'm going to go to Google and say, look, I want Google Apps. I got 1,000 users. Hook me up. As long as I have internet access from wherever that user is to the Google Cloud, you have your word processor, your spreadsheet, your email application. Or I go to Microsoft, right? Microsoft would love to sell me Office 365. $5 a user per month. I get a premium access if I want. Somewhere down the road, that also means I have to migrate everyone's mail out to the cloud. That's going to be some security concerns and issues. And then we're going to talk about a hybrid cloud. So that's software as a service. And again, your Office apps would be the most common usage for that. Again, driving forces here, cost. Will I save money going to the cloud? Maybe. All right. There's no definite answer yes. There's no definite answer no. You could save quite a bit of money going to the cloud or moving some part of your infrastructure to the cloud. But you may lose money moving other things to the cloud. There may be situations where there's certain things you cannot move to the cloud based on your business model or compliance regulations. I can't move this to the cloud. I have to keep it internal. It always has to be internal. But I can move this to the cloud, and I can save X amount of money over the next 18 months to 2 years. All right, so that's going to be part of your design process, is to figure out where you can and where you can't. But costs. Implementation time, we mentioned that a few times now. Again, I can fairly quickly spin things up. Fixed per user, per month feature, per month cost also allows faster implementation, as there's no need to deploy on-premise infrastructure prior. Infrastructure is already in the cloud. I just got to log in and say, go, and then start doing my stuff. Accessibility, well, as long as your users have access to the internet, as long as the users accessing the application have access to the internet, then they will have access to your application. All right, so as long as the cloud is running, then your stuff should be there as well. And as we mentioned, elasticity allows adding and removing users or services based on how much you want to spend or based on how much workload your application is getting. I'm going to have an analogy coming back to that in a little while. Now, we want to break down a couple more important topics. Public cloud versus private cloud. All right? The public cloud is obviously something that's available to the public. Self-service, dynamic provision resources, services shared by many organizations. So your company, my company, that organization, that government entity, we all can go buy access to the same public cloud. And it's the cloud provider's choice, it's the cloud provider's rules, it's the cloud provider's controls that separate all of our data. All right? And hopefully we do that very well, because I don't want my email popping into your message system. I don't want my SQL database being accessed by your applications, or maybe I do. All right? So we can set those kind of scenarios up. So the number one thing here, a problem with public cloud, of course, is security. Is my stuff going to be secure? Will my data be secure? Sure, why not? Is it secure on your internal network? Well, yeah. How do you know? Because I make it secure. Well, it should also be secure in the public cloud, as long as your provider, again, has the proper things in place. Picking a cloud provider is what's important. Having said that, depending on what your data is, you may still not want to move to the cloud. All right? If I'm a banking institution, I'm pretty sure there's some regulatory systems that say I can't move this data to the cloud. If I'm in healthcare, there's a whole HIPAA thing that says I need to be careful with certain data, right? Or I need to find a cloud provider that offers those types of compliance regulations. So again, your big three I'm going to talk about today: Amazon Web Services, Google's Cloud Services, and obviously Microsoft Azure. All three of those pretty much fall in that boat. They will offer you, they do comply at those highest levels. So your data will be secure. Probably your biggest concern is the data in the cloud secure, the data on-premise was secure. How do I get it in the cloud? And did I keep it secure while it was flowing up to the cloud? That's on you. All right. So that's encrypting your data before it leaves. That's encrypting the tunnel between you and the cloud provider, and that's maintaining that solution. Typically provide infrastructure, platforms, and storage. So your big public cloud providers basically give you infrastructure as a service, platform as a service, application service. They give you all of those things, and they are constantly growing and adding new features. So Amazon, Google, Microsoft Azure, Salesforce.com was one of the first big cloud service providers. Now the other side of this is private cloud. Private cloud means basically using all of these tools, all of these features, all of these applications to make a cloud, but you're keeping it internal. You're keeping it on your network. So if you're using virtualization internally right now in your network, are you a cloud? Maybe, maybe not. But you're at one stepping stone closer. All right, so if you've got VMware, you've got Hyper-V, and then you've added things like flexibility and resource pooling and elasticity and all those other things that kind of go with cloud services, then yes, you have your own internal private cloud. You're able to spin things up real quick. You're able to monitor things very easily. You're able to orchestrate changes and modifications very automatically. That's a cloud. It's just for your stuff. Why do I do a private cloud? I already had bought the hardware. I already had all the stuff in place. I've been buying licenses for VMware for years now. I don't want to rip all that out and dump it off to somebody else's cloud. I've already got a cloud. B, there was that security thing again. I had a certain amount of data, I had a certain type of data that a whole lot of people were nervous about putting in a private, somebody else's network cloud thing, so we had to keep it internal. So we spun up our own private cloud. So So it allows organizations to utilize and extend their already investments into virtualization, offers higher level security and confidentiality. And then some examples. Microsoft Server with Hyper-V 2012 and System Center 2012, right? Those two things go together to make a private cloud in Microsoft's world. VMware, vSphere, vCloud, all their current products, that's all private cloud implementations. And you've got other vendors, of course, that offer many other solutions. Lady after me is going to talk about IBM, and you're going to hear all about IBM's solution, which is very good. So kind of a comparison and contrast. This slide's a little small, but again, the things we just talked about, benefits of public versus benefits of private. Benefit of private would be the security. Benefit of public would be the no heavy-duty initial upfront costs. Major concerns of public would be your security possibility. And vendor lock-in, we'll mention that again later. Vendor lock-in basically means if I created an application in my current cloud vendor, and then I decide I don't like that vendor, or they've changed their service level agreements to a point that it's no longer where I want to be, and I want to move that application to another vendor, how easy is that going to be? All right, I use a particular development platform here, and now this other vendor is not 100% compatible with that, so it's going to require a certain amount of rewriting of the product. So I have to be aware of that going in. Other major concerns of private cloud, of course, is the maintenance. You're still maintaining all your systems. You didn't roll that off to somebody else's problem. Limited provisioning capabilities. Well, that's based on how you build your cloud. Right? If you have a proper orchestrator and you spent the time to come up with all the scripts and all those plugins, then yes, you should have decent provisioning capabilities. And then network outages. Well, that's like anything. It's still your network, it's still your infrastructure, so you have to maintain it as usual. Now, I'm going to mention here one brief thing about the hybrid cloud. In those situations where you have data that you cannot legitimately put in a public network, all right? I can't put this stuff in a public cloud, but we want to use a public cloud for other things. I can do both, all right? I can leverage my existing internal infrastructure, use cloud-based applications and virtualization and so forth for this critical data, and I can move a whole bunch of other things off to the cloud. An example of that is a speech I gave actually 2 weeks ago at our office here in Baton Rouge, a hybrid email. I've got an Exchange deployment already on premise, Exchange 2010, Exchange 2013, dozens of mailboxes, hundreds of mailboxes, dozens of databases, but I want the fast, easy access for certain users. Then I can pick and choose certain people to move out to the public cloud, Office 365, but I can keep other mailboxes and databases back on my hybrid on-premise solution. So I'll be running both an on-premise Exchange environment that's tied in with a cloud-based email system, which is Exchange 2013 and Office 365. The downside is it's a very complex setup. All right? It's a lot of things that have to happen before your on-premise stuff, Exchange, Active Directory, global catalogs, will communicate with that cloud solution. So there's extra things that have to be monitored, maintained, troubleshooting, so forth and so on. But that is an example of what's called a hybrid cloud. And then finally, a bare metal cloud. There are situations where I have an application I'm already using in-house. I want to move it to the cloud, but I need ultimate control of that system. All right? I don't need just a virtual machine running Ubuntu or CentOS or Windows. I need an actual physical server that I can maintain. I need to find a cloud provider that will give me a bare metal cloud. All right? They're going to give me a specific piece of equipment that's in their data center. I'm going to have 24/7 access. They're going to obviously manage the hardware side as far as power and network and environmental systems. But I have access to that system, and I can do whatever I want with it, based on, of course, a certain monthly fee. So bare metal cloud may be used for high volume, extremely high performance workloads, high disk intensive workloads, or possibly again for compliance regulations. I can't, in certain situations, they'll let me move the data to the cloud, but the application has to be on its own machine. All right? Your public cloud provider, they really want to give you access to a virtual machine, but they also want to give other people access to virtual machines on that same physical hardware. All right? That's the idea behind a public cloud. In this situation, no. I want that machine dedicated to me. Whatever VMs are on it are for me. I'm not sharing processor, disk, network activity with other vendors or with other clients. So that is a bare metal cloud. How do I get here? Well, there's some Specific migration challenges, obviously legacy systems. Not everything is going to be compatible. Some things will have to be rewritten. Some things just can't move to the cloud very easily in the current generation of that application. So if it's a commercial piece of software and you want to move it to a cloud solution, there's a lot of concerns. So I'll have to look at those, I have to inventory those applications. Service level agreements. I have to know going in with the cloud provider that I've chosen, what are their current agreements on how they're going to provide all the features they offer, and can I live with those? If they change their SLA, how much lead time will they give me before they do it for me to back out and make a different decision? All right. Don't lock yourself in necessarily if you can. And then, of course, security. How do they handle security? How do they handle security incidents and responses? What will they be responsible for? Notifying you. What will you be responsible for as far as monitoring and maintaining your systems? They're in somebody else's network, but at some level, it's your stuff, right? So these are migration challenges. What are your risks to your organization? Obviously, security is the big concern for most people. And the first thing I have listed here, where is your actual data? You push it in the cloud. I call Microsoft right now, and I start throwing data in a data store somewhere in Microsoft Azure. Where will it be, and do they let me control that? Microsoft's got data centers all over the world. There may be situations, there may be reasons why I can't have my data outside continental United States. There are privacy laws all over the world, and I may be subject to dealing with those issues. All right? So I need to know where my data is being stored, where my backups happen in the cloud. Is there any offer for geographic redundancy? Technical failures destroy your stored data. Backup's a backup. Just because your stuff's in the cloud doesn't mean you stop doing backups. All right? Cloud is a wonderful thing, but it's not magic. Issues around data retrieval. If the cloud provider goes out of business, is Amazon going to go out of business anytime soon? Google, Microsoft, IBM. Pick a cloud provider that has a good track record. And you never really know, Enron, what could happen to that. But still, you're going to probably have some indications of a problem well before they turn off the lights and start selling off hardware. Unauthorized access by other users should not happen with your data. Vendor lock-in, we mentioned that earlier, creating systems at a particular cloud vendor and then deciding you want to change to another vendor. How locked in is that application to that platform, and can I make it work on another platform? Loss of management control, that is a possibility. Again, you're being given an interface, access and monitor all of your cloud systems. Who else has access to that interface? Does the back-end people have access as well? What do they give you access to? What do they not give you access to? And as we mentioned a few times, compliance with regulations. You move your data to the cloud, but I'm required every quarter to be audited. Can the audit team get to my data? Can I give them an interface? Do they have the same controls and mechanisms to let them scan through that information, looking for information, right? So let's say it's email that moves to the cloud, and we have a legal issue where I have a legal team coming in and they want to look for specific emails, organization-wide. And you'll be able to hit every mailbox on every database looking for certain parameters. I moved all the emails to the cloud. Well, you should have thought about that, because you're the one with the subpoena, right? Your name's on that piece of paper, and they want email, and you got to provide it. Oops, don't want to be there. So think about those things. From a developer standpoint, provisioning resources. We're going to write this application, or maybe it's already written. We already have it in-house. We want to move it to a cloud-based system. Know your application. Obviously, know the platform it was based on, but know the resources it needs right now, because you're going to have to create that environment also in the cloud system. And once you move it to the cloud, you may actually be opening it up to more people. Plan for that too. Now, many of your cloud providers allow that elasticity, but that also affects your cost. All right, so incorrectly provisioning your systems in the cloud are some of the reasons why cloud solutions fail, or cloud solutions cost more than you think. And you want to break it even if you're lucky. As I said, you may save money, you may not save money. Server crashes, distributed denial of service attacks, these are all security issues you're already dealing with. Nothing really going to change that dramatically. Well, some ways in the cloud that will change a little bit. Obviously, your cloud provider is providing lots of extra resources and has very good monitoring capabilities. But all those things come sometimes with an extra cost. So I can't just assume it's happening. I need to know what my service level agreement say about it. Under provisioning of resources, what we just mentioned, compromise of control measures. If you go make an Amazon account and you attach that credit card to that account, you have access to whatever resources you create, whether it's virtual machines or data stores or databases or whatever. Well, anybody gets that account, guess what they have access to? All of your resources. So I have to keep, again, a controlled account environment, just like I would with internal resources. Technical and security issues. Interception of your data in transit. And this is a common concern for most people who are thinking about moving to the cloud. How do I get the data in the cloud? Well, is it secure right now on your private network? I think so. The cloud provider is going to provide secure storage for your data. Great. How am I going to get it there? Your cloud provider is going to give you the capabilities of creating VPN connections. Right? So you're going to treat the cloud provider and their data centers as just another location on your network. You've got 5 offices now, well, you're not going to have 6. That 6th office, you'll make a VPN connection to that cloud provider. You'll have plugins to your specific area of resources. You'll test that connectivity, and you'll move your data out there. All right. So as long as your data is secured between the facilities, it should be secured as well on the other end. But your other concerns, if you're using encryption and encryption keys to keep that data secured both in transit and in the cloud, who owns the keys? If your cloud provider provides all the certificates and all the keys, but they control the private key, they control the certificate, they control your encryption. All right? Maybe that's part of the agreement, but maybe I can't live with that. Depending on the data, that's not where I need to be in 100% control of the entire process. So that, again, may be a piece of data that I either don't move to the cloud or I have to find another scenario. Maintenance outages, planned, unplanned. How do they handle that? How much leeway do they give you? Hey, we're going to have an outage in all data centers on Friday afternoon, and it's Thursday morning. That's not enough lead time. I'm going to have a complete network outage Friday from 5 o'clock till who knows when. I needed 2 weeks planning for that. Well, it's an emergency. I know it's an emergency, but help me, please. All right. So, knowing going in what their plans are, what the agreements are to handle that, is very important. Risk to the service engine. I don't think this is as much big problem as it used to be. Again, all of our cloud providers, the big ones, are pretty good handle on this thing, unauthorized access to your applications. Again, if you've got somebody hacking your main workstation where they stole your account credentials, then yes, they can hack into your cloud resources, but that's security 101. Illegal entry to data in the customer environment, that should be handled by the cloud provider. Hacking the virtual machines in the cloud, that should be handled by the provider. But if it's infrastructure as a service, yes, they have certain things in place, but at some point, it's your virtual machine. You're the one in charge, you're the one controlling what you did with it. You never patched it, you never did anything with it, and you made network connections to the internet without any restraints, you're only blocking certain traffic. So at some point, it is your responsibility. Legal risks. First thing I have listed is a change in jurisdiction. You stored data in the cloud, you checked off a whole bunch of boxes about making it highly available because you wanted to use the cloud as part of your disaster recovery business continuity plan, and yeah, they're going to take your data and they're going to have it automatically dispersed across 5 different regions of the world at all given times. And if one data center goes down, your data is automatically going live somewhere else. But you forgot that they've got data centers in Scotland, they've got data centers in South Africa, they've got a data center in South Korea, and all of those countries, even though it's your data hosted by one provider, each country has different laws on how they protect data, privacy laws and so forth. And again, that might break some of my main compliance issues. So I need to know that, I need to control that. A lot of providers, a lot of cloud providers allow you to specify where you want your data geographically stored and so forth. Unwanted data disclosure, what's that lead to? Licensing, I mentioned that here. In fact, I think I have another slide that goes deeper into licensing. Licensing risks. If you're putting commercial software in the cloud, right? I spun up a virtual machine and I installed this application that I bought for on-premise use. I'm now putting it in the cloud. That needs licensing, all right? And then I build into my cloud provider's scenario When the workload of this passes a certain threshold, I want 2 more virtual machines to automatically fire up and a script that's going to automatically install the app again and synchronize it, and now I've got 3 systems. Well, now I need 3 licenses. All right. So your cloud provider is not managing that. That's still up to you to manage all of your licenses. So commercial software needs to be licensed, whether it's used internally or in the cloud. Your elasticity options may cause you to have to think that through. So moving your business continuity to the cloud, this has been another important thing. This has been a popular thing a lot of people think about. Instead of me having to have another data center 150, 300 miles away with equipment and internet connectivity and VPN connectivity, and I'm weekly doing test failovers, and I'm hourly sending data over there, but I have another facility to manage as part of my backup plan. Why not put that in the cloud? All right, that's a facility I know how long I have to pay rent for. That's electricity, that's HVAC controls, that's all the things of a physical place, equipment and everything. But you have high redundancy, high reliability. Assuming your cloud provider doesn't fail, and assuming you always have access to that cloud provider as far as internet connectivity and so forth. All right, so those are still the concerns, but those are already concerns. So I can actually save a little money, possibly moving some of my business continuity features to a cloud provider. Storing data on off-site locations, performance in the cloud is scalable and elastic. All these factors affect, of course, the dollar signs. So the more little neat things you see on your cloud provider's options. Oh yeah, well, that looks good. Slide it over here. Ching, 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 right? So disaster recovery, easy deployment, rapid provisioning, highly scalable, and it can be very much cost effective. And as I find new things that I need to make more highly available, sling them in the cloud, sling them in the cloud. Concerns, limited application support, insufficient bandwidth. If I'm trying to do backups to the cloud right now, well, how much data do I have? Cloud provider easily gives me that much space to do it, but my biggest concern is my internet pipe. Right? Moving several hundred terabytes of data to my cloud provider over a 5 megabit per second internet connection is not going to happen. Even if I give them a copy of the stuff and I just want to send the daily differentials or incrementals, I'm still choking on that. Right? So where is my main data center now? Cloud provider, and how much internet connectivity can I have to it? I recently taught a class in our Lafayette office. It was a relatively small law firm in Lafayette, and they were moving completely to Office 365. All right? So they got 20 or so lawyers, and then all the other people that go with that. Nobody apparently had ever deleted an email, so they've got massive amounts of mailboxes and databases, and they want to push all that to the cloud over a T1 connection. And it ain't happening. Right? It's choked all day long, and it took a week for 2 mailboxes to appear. So they had to put the whole thing on pause, had to call an internet provider and say, we need more bandwidth. Thankfully in Lafayette we have a fiber optic option. So LUS Fiber came in and dropped down a gigabyte. Gigabit per second internet, here you go. And 2 days later the whole thing was in the cloud. So that is a concern. Challenges with backup to the cloud, as I just mentioned, bandwidth, security. Don't forget to make that connection between you and your cloud provider secure. VPN, high levels encryption, latest encryption standards, and what's the time frame on recovery and stuff. What are the problems with recovery? If I go lights out and I'm going to be without power and internet for 2 days, well, I know that all my data is in the cloud, but how do I tap into it? Still need another place with some hardware and start pulling those backups and storing data, assuming I have power somewhere else. Now, one of the neat things about cloud systems is the ability to easily, in some cases, scale up or scale out. Scaling up basically means I created a virtual machine, let's say. I chose at that time to create with 4 processors and 16 gigabytes of RAM and some storage solution. And I dropped my application on there, and great, it's working fine. 6 months later, the project has been a huge success. We've got hundreds of people extra now tapping into the application, using it daily, and we're starting to see performance loads on that system well beyond what we prepared for. How do I fix it? Well, if I try to scale it up, that means actually going back in and assigning it more processors, or more RAM, or faster disks. that will probably require some downtime, right? On anybody's virtualization process, if I want to add more processor cores, more RAM, there's only certain things I can do while that VM is running live. So there will be a small downtime for maintenance to scale that up. But if my application supports it, I could scale out. And again, that can be easily orchestrated in the cloud system. Current server is running here. Well, again, when we meet a certain threshold, it fires up automatically a second server with all the proper parameters, drops over a copy of that application. They're both tapped into the same data store, and I create some network load balancing scenario. Boom. I've scaled out, I'm double performance. Oh, go to triple, go to 10 times larger. Pizza anyway, all right? Quick analogy, 5 minutes. Let's say I'm a very large national pizza chain. What's my busiest time of the year? Super Bowl Sunday, right? So I've got a wonderful online order system. Works flawlessly, it's wonderful, taps into every location that I make pizzas from. But I know Super Bowl Sunday is going to be crazy, right? So right now, 364 days of the year, I have in the cloud the resources to do my daily job. Thursday before Super Bowl, I go to my cloud provider and say, double that. Go. And they start spinning up systems. All right? So virtual machines start popping online, and applications start dropping in there, and it's all organized, orchestrated, and scripted. And now my capacity for that to drive and run that e-commerce site has doubled. So that's the Thursday before Super Bowl. What do I do on the Friday? I schedule it to spin up and double it again. So now 4 times what I originally was. And it's all automated. I did this 10 o'clock at night from a laptop in my house. Thursday do this, Friday do this. Saturday, quadruple what you have on Friday. Sunday, quadruple that again. Because I know from last year how much business we have running through our website. So I'm spinning up systems as necessary automatically in my cloud provider's interface, and they're doing all the work on the back end. Now, does that mean that my cloud provider has a bunch of engineers plugging in servers and running cable? No, it's all automated, all right? They were doing that 10 years ago, but now it's all scripted. And they have a nice, easy web access interface where you can just slide things over and create a schedule on when I want to go to the next level. So by Sunday, my e-commerce website for ordering pizza is this massive thing, and we're taking orders. No hiccups. The website's working great. I don't know about the guy making pizza or the lady driving around town with a hair on fire, but yeah, we can take your order as quickly as possible, just like it was a normal Tuesday of any kind of period. What happens about halftime, let's say on Super Bowl Sunday? I shrink it down. Nobody's ordering pizza anymore. I shrink it down about half of where I was. And then incrementally every 3-4 hours, I keep shrinking and shrinking and shrinking. And then somewhere by Monday afternoon, all the hubbub's over, I got my website back down to where I was. Did I buy more equipment? Nope. Did I have a bunch of temps come in? And nope. I scaled up as I needed. I scaled back down as it was. Microsoft or Amazon or Google charged me for what I use, and I'm back to where I was. All right? So that's the scale-up, scale-out architecture. And again, your cloud provider should have all the proper orchestration for helping you do that relatively easily. Running out of time. Let's see, security compliance. Again, our biggest fear factor with cloud, especially public cloud, is still the security concerns. So I'm going to go in lightly. I'm going to take the low-hanging fruit, the things that I'm already putting on the public internet, and I'm going to move those applications to my cloud provider and see how fast I can do that, how efficient those things are, and then I'll keep moving into other areas of my infrastructure, moving more and more applications to the cloud. But those high security features, I may still never get them, and may stay in-house at all times. So security scheme is an expense. Planning incident response, I have to go and know again what my cloud provider is going to be responsible for, what they think I'm responsible for, and hopefully won't have any incidents to worry about. Overall, most security concerns we've had for several years have been met and are mostly diminishing. Identity management, who's accessing your applications? You should have a way of controlling that. You should have a way of developing that. You should have a way of tying that into your current identity management. All right. So if I'm using an internal application and I'm tying that in with my current Active Directory user accounts, I want to move the app to the cloud. Well, can I still tie it in with these accounts? Absolutely. All right. Single sign-on is alive and well, and I want to be able to use them. Detection forensics. A lot of your cloud providers now offer that as an add-on feature. For certain applications, I need to heavily monitor traffic. I need to have some type of network intrusion detection system or prevention system looking at that particular VM and all the traffic and do these things when something happens. All right, so your cloud providers are starting to have those features. And as we mentioned, data encryption, both in transition to the cloud and then once it's in the cloud. As far as standards, Microsoft and Amazon have been working feverishly to meet some of these high-level standards. Amazon actually has Amazon Web Services for Gov. That meets several federal standards, FedRAMP, HIPAA, and the Criminal Justice Information System regulatory compliance. Microsoft is working on a similar feature. It's in testing right now, but you can actually sign up. If you have apps ready to go that you want to test in this foreign government cloud solution, you can sign up at Microsoft for that feature. We mentioned encryption important, both in place where it is, migration to the cloud, and once it's stored there. Again, a question to ask your cloud vendor, who's going to own the keys? Whether it's on-disk encryption, it's network traffic encryption, whatever. Do I get to control that, or are you going to have my keys? I may not want to do it. Return on investment. Cost saving by shrinking your IT infrastructure. I spend less money on hardware potentially. I spend less money, therefore, on cooling the hardware, powering the hardware, maintaining the hardware. So that part shrinks. But I still have systems to manage. I still got all the same servers. I still got all the same applications. I still have all the end users. I still need to manage all that, so I still have all the same people. Anytime they have left over, or they're not swapping out a hard drive or changing a bad power supply, they're going to be going around and saying, what are your pain points? Oh, well, we have this application and it works okay, but it would be really nice if it did this, this, this. Well, we can do that. We can develop new features because we have all these extra resources that are availability, and we're more efficient now, all right, because we moved to the cloud. Better predictability. Proper SLAs allow you to basically understand exactly what's going to happen when it happens. Better visibility. Who's using the apps? How much data are the apps using? How much network traffic? How much disk resources? I get a lot of controls. I get a lot of reporting once I move my information to the cloud. So, where do we stand and what's the future? Last slide. The future is now. According to Gartner's hype cycle, the cloud is now way over here at the end. The plateau of productivity. So we passed all the initial stuff, all the initial hype, all the peak of, oh, the cloud's going to do everything for us. The cloud's going to make a better piece of bread. The cloud's going to make a more efficient internal combustion engine. Now, all that washed out. We had the slope of disillusionment. All right, that's this part here, trough of disillusionment. And we're now moving into third and fourth generation cloud products. The stability's here. The security issues have been solved for the most part, and high levels of growth. So if you're not in the cloud, you should be in the cloud. Be prepared for the cloud. Now, I do work for a Microsoft partner, so just a little extra plug. Microsoft Azure has been the one growing. IBM and Microsoft pretty much the ones growing at the highest levels. Amazon owns the public cloud. All right, Amazon Web Services is number one. Microsoft has been trying and has recently been positioned as number two. And they have now brought up their 19th worldwide region of cloud services. Each region has 16 data centers. So Microsoft is saying they are now physically twice as big as Amazon, 6 times the size of Google. They're also recently brought up a new G series of hardware, where you can now spin up virtual machines with up to 32 processors, 450 gigs of RAM, tons of hard drive space, and a lot of that's solid state space. High storage capacities, 50,000 IOPS per VM with 1 millisecond latency. Microsoft spends a lot of money. I think right now they spent up to $18 billion on Azure, bringing that online. Amazon's the one that's most efficient. They're number one, they spent the less amount of money actually creating their cloud service. So they're the one to beat. Amazon is the number one. Microsoft's saying they're actually bringing online up to 10,000 new Amazon or Azure customers per week. Now, if you are looking toward Microsoft Azure as a training provider, they are providing us now with several courses. We have actually 4 to 5 new classes dealing with Azure stuff. We have a 2-day one, just the fundamentals of how to work in Azure. We have one for developing in Azure. That's a 5-day class. We have one for infrastructure. How do I spin up virtual machines? How do I work with SQL databases? How do I handle network connectivity? 5 days with Azure. We have 2 for private cloud. All right, so if I don't want to go the whole public cloud thing yet, but I definitely want to implement my current hardware with a private cloud, and Microsoft's pretty aggressive on the pricing, licensing with Hyper-V versus VMware, then Microsoft's option private cloud is Server 2012 Hyper-V and System Center 2012 R2. We have 2 courses for that, and actually 2 certifications if you want to get certified for that. So there's a monitoring and operations course, and there's actually a configured deploying class. These are very difficult courses. And that's it. So if you're not in the cloud yet, you should have already been thinking about the cloud, and hopefully I've talked enough about convincing you to get there. Start playing with it. You can sign up right now for 30 days free trials of all of these providers and start tinkering with what they offer. Thank you.
Thank you. Ladies and gentlemen, don't